Debugging Kubernetes is always hard, and we keep on looking for new and new tools that can do it effectively and efficiently. Also, whenever there is a request from any application it always goes via the kernel in order to access the file system or whatever it is. So it's done via the syscall, which is done by the kernel. So that's how the usual typical flow goes. Now, the tools utilizing the eBPF, which in short means that inside the Linux kernel, there is a program that can be run. That typically means that you can actually run a program at the operating system kernel level. So eBPF technology changes everything at the ground level, root zero. It allows the programs to be run in an isolated sandbox environment securely and safely, just as it was the kernel code itself. And most of the fundamental use cases for the eBPF are powering the networking observability and security. In Cilium, we already see how eBPF is powering the networking. And in this video, we'll be discussing one of the observability tool that is powered by eBPF, which is called the Inspektor Gadget. Before moving further into the video, I would like to thank Cisco, Commodore, Sysdig, Slim AI. See, these organizations are helping me and they are my org members, and that is why I am able to create such content. So make sure you check them out. The more you check them out, obviously, the more benefit it will do to me, and I will be able to produce similar content like this. Links are in the description of these, and they all have very cool projects to check out. Let's move to Inspektor Gadget and learn all about it. So Inspektor Gadget is a CNCF sandbox project. As I mentioned earlier, it is based on eBPF. So it is a collection of eBPF-based gadgets to debug and inspect Kubernetes application and resources. Now, it manages the packaging, deployment, and the execution of the eBPF programs. And eBPF programs, I told you, runs at the kernel level. And it includes many which are based on the BCC tools. Now, what is BCC? BCC is BPF compiler collection. So that is a toolkit for creating efficient kernel level tracing and manipulation programs. And these are very useful tools. So how Inspektor is positioned, it's basically the tool that is required to investigate the cluster's toughest issues. It expands the BPF usage from single node across to entire cluster, this is very important, it maps the low-level Linux resources to the high-level Kubernetes concepts so that you will be able to understand it better. And you can use it standalone or integrate into your own tooling. So eBPF-based tooling for investigating and provides wide variety of BPF tools to dig in your Kubernetes cluster. So these are some of the tools. Or you can say gadgets, because that is what it mentions, like Inspektor Gadgets, and it's full of gadgets. So there is an advice gadget in which you have network policy that monitors the network activity in specified namespace and records a summary of TCP and UDP traffic, SECOM profile. You have auditing that provides stream events with syscalls that had their SECOM filters generating in audit log. You have some of the profile gadgets like CPU takes the CPU sample traces of the stack trace, snapshot gadgets that gathers the snapshot of the TCP UDP sockets, like it has to top track active TCP connections, track reads and writes by the file with the container details. So I think these would really help in getting those issues fixed. So before moving on, let's try to recollect what we have learned. So far now you should be knowing at least that eBPF program is kind of a bytecode that is loaded inside the Linux kernel and that executes whenever there is an event happens. And then the Inspektor Gadget will enrich the data at the Kubernetes containers, all that information, and we can take out from the ring buffers from the user space. So the eBPF programs are run by the kernel very securely. Now, on a high level, we just saw that there are a few categories in which the Inspektor Gadgets, the gadgets are there, like the advice gadget that gives you the advice of creating the network policies. Then you have traces, which are very important one, top, audit, profile, snapshot, all these are there. But now the Inspektor Gadget project is actually moving into the direction where it is adding more and more interesting features. What are those features? Let's talk about that. So the first one is having the Inspektor Gadget outside of the Kubernetes cluster. So basically, there is now a tool, a CLI, which is called IG, and that is a CLI tool for the Linux host. For all the cases where the tracing is to be done without going through the Kubernetes API server, you can use the IG tool to get the information and the insights from the nodes and then debug it. So how you can use IG is you can debug the standalone containers, you can debug when you have root SSH to the nodes, and you will be able to get insights from the application that is running from a particular node. So you can go into that node and run the IG command for that particular container and get the metrics out of that generated, or get the observability out of that and debug it properly. The next one, very cool one, is the Prometheus metrics. So Prometheus metrics gadget collects and exposes the metrics in the obviously Prometheus format, and it is both available for IG and for the Kubernetes, both available. So you can do either IG Prometheus and config the metrics list and address of that, or you can do the kubectl gadget Prometheus and use the config path which is there, and then you can do the regular filtering to even enrich the data and then create fancy Grafana dashboards based on that. And the most interesting one that is coming up actually is the bring your own eBPF code. So I think that is very interesting because it uses something which is called the Bumblebee project. So Bumblebee project is by solo.io. I actually tried that out and tweeted when the project was just launched. So you can actually package your project as an OCI artifact and then push it. So the Inspektor Gadget basically will be able to run your own eBPF program by providing that particular OCI image. So I think these are very fancy features. So let's see these new features in action first, and then we move on to some of the core features of Inspektor Gadget. So the first thing that I have here is I have installed IG. You can install either IG from the latest releases page, like download the binary from there, or you can build from source. I have actually built from a different branch because I wanted to show you something. So basically right now I have IG, and you can see there are various commands like audit, completion, list containers, profile, Prometheus. So obviously the two new ones are the run and eBPF program, which is not yet released in the released version, and next one is the Prometheus one. So for the run one, running your own eBPF program, so you can do the run and then provide the image. So this particular is by Bumblebee oomkill, or you can give the TCP one. Now, right now it won't work because it is not supported. The kernel is not supporting that particular process. So I can try another one as well, the TCP connect one. So this again is not working because it's not supported. But yeah, this will be the way that it should be running your custom code with the IG command. And you can directly run the OCI image or provide the --prog, which is kind of used for the development purpose, and the output will be in the ring buffer format. Now let's try the Prometheus one. So the Prometheus gadget collects and exposes the metrics in the Prometheus format. So let's try to do that. First, let's apply the Prometheus.yaml file. So it creates the namespace, deployment, and all that. Basically, it's creating the Prometheus from scratch. So we have Prometheus up and running. What I have done additionally for this is I have exported it as a node port so that it can work with Killer Coda, very shortcut way for doing that. What we'll do next is we'll create a config so that we can create a metric that reports the processes that gets executed. So let me create that by config.yaml, pasting it. Now let's run the gadget with my config.yaml. It is publishing metrics from node 1 and the control plane. So after refreshing this page, we'll be able to see execute total processes. We can execute this and we'll be able to see the graph for that as well. So if I expand, you'll be able to see the graph climbing up. You can see all the executed processes which are there. So this is how you can export the metrics as well in the Prometheus format, and even you can create fancy graphs in Grafana dashboard. So let's now create a pod so that you can have more number of processes. Now you can also change the configuration actually. So you can do the my config change. And in this, we can actually add the selector command. So it will only capture the cat command. So what we'll do is we'll start this again and we'll run a particular pod which is actually creating only the cat command. So let's do that. And now if you see, things have changed. You can see the abnormality in the graph, and you can also see that my pod 1 and the other previous jobs which were there, they have given a lot of crazy metrics which is there. So what I did was I have created a couple of pods. Like for the previous runs, I created ping, localhost, and created multiple processes. And that is why in the Prometheus, we are able to see, so many processes. Like we can also filter by, so you can see my pod 1, my pod 2, how many processes they have created, 100K, 200K, 2K processes. So these are the set of processes which are created. And based on this, you would be able to create the fancy graphs and all that stuff. So I think the Prometheus one is also pretty fancy. And you can also run this Prometheus via the IG command. And also with IG, you should be able to list the containers. You should be able to run the trace commands and get all the traces which do not require the Kubernetes cluster. So I think IG is pretty fancy, and then you can run your own BPF programs. But as of now, with the release, you won't be able to do that. You have to build from a specific branch, which is tricky job, but you can still read the design. So in the doc section, you should still be able to read the design docs for the Prometheus, bring your own eBPF programs and how to run that, and then the IG as well. So you should be able to read all these. So I think Inspektor Gadget is not only, apart from its core features that we'll be discussing next, it has improved a lot and it is adding new and new capabilities. Another interesting one is their new project Headlamp. I already created a video on Headlamp. So they are planning to integrate the Inspektor Gadget with Headlamp as one of the plugins, which will be super cool. Now let's move to the other parts of the Inspektor Gadget and understand some of its core capabilities apart from the fancy new ones that we have just seen. But first, let's go to our overview. So how does it work? Inspektor Gadget is deployed to each of the nodes as a privileged daemon set. So there will be a daemon set that will be deployed. It uses in-kernel eBPF helper programs to monitor the events mainly related to syscalls from user space programs in the pod. So what I mentioned in the beginning of the video, the syscalls will be monitored. The eBPF programs are run by the kernel and gather the log data. Inspektor Gadget's user space utilities fetch the log data from ring buffers and display it. Let's have a look at its architecture as well. So it comes with several tools which permit monitoring different events related to specific kernel subsystems. What that means is, first of all, it is deployed using kubectl Gadget plugins. So we'll be having a Gadget plugin. It interacts directly with the Kube API server to create all the resources needed for the Inspektor Gadget to work. So another way would be directly applying the manifest using kubectl. So it will be deployed on each node as a daemon set. So as you can see, we'll be having the kubectl Gadget deploy that will be having that will create the daemon set which is there and interact with the API server and then deploy the gadget pods. So Inspektor Gadgets provides the trace custom resource definition. So as users, you'll be creating those custom resources, and then the gadget pod implements a Kubernetes controller that performs the action as per the custom resource that has been created. So you can see it installs the BPF program which is there. Events are read from the kernel buffer, then the events are published to the stream. Now let's try to install it. So we'll use Killer Coda for this. kubectl get nodes. So let's install kubectl Gadget. So in order to do that, first we have to install Crew. In order to install Crew, we have to come to this website. Let's copy paste this. Export the path and kubectl Crew. And it's running. So after installing Crew, we need to do the Gadget install. So we'll do kubectl Crew install Gadget. And now what we are going to do is we'll just deploy it and see what all resources it will deploy onto this particular cluster. So you can see it is creating a namespace, service account, role binding, cluster role binding, the daemon set, and the CRDs that will be creating custom resource to do the traces, and then the controller will do its job. So the inspector gadget has been successfully deployed. We can check that kubectl get pods -a, and we can see in the gadget namespace, since we have two nodes, we have a control plane and the node. So that's why we have two pods which are in running state. Now let's try to do one of the demos. So we'll use the advise network policy. So the network policy advisor monitors the network activity in the specified namespace and record the summary of the TCP and the UDP traffic in a file. This file can be used to generate Kubernetes network policies. So let's run the demo. So first we'll do kubectl create namespace demo. So after creating the namespace, it says we should deploy this particular PSP, disable PSP demo YAML file. It just has the role and the role binding. So in tab 1, we are starting the gadget advice for network policy and monitoring in the output file this. And then let's move to tab 2 to do rest of the command. So what we'll do is we'll deploy this particular manifest network policy demo. So let's deploy this in the namespace demo. And yes, it will do a bunch of deployment and services, a complete application kind of front end, payment services, and all the other stuffs, even the load generator which is there. So let's see, all the pods should soon come into running state. And most of them are running or initializing or container creating. All the pods are in running state. So it says generate the network policies now. So we'll try to generate the network policy and ask our inspector gadget to advise on that. So let's generate the network policy and let's see what network policy it has generated. So a lot of network policies are generated. So for example, in this particular network policies, you have an egress, which is allowed to this particular namespace matching this particular pod selectors, and ingress from pod selector front end. For the cart service network, it can send the traffic to app Redis cart, all the pods with matching the labels Redis cart, and receive traffic from the application front end. And in this particular network policy, you can also see that it is ingress, it can receive traffic from the checkout service. So it has generated the network policies for us. So it's time to apply these network policies. Let's apply that. All the network policies are created. Now let's redeploy the demo. So we delete it. We apply this. And we can see all the pods getting into running state again. So basically the advise gadget will actually advise you based on the captured traffic. So let's try now the top gadget, which shows the current activity sorted by highest to lowest in the resource being observed, generating the output every second. So let's do top TCP and let's run this particular pod. Pod is created. So here we have used kubectl gadget top TCP and we are trying to put in all the events in the TCP events.txt file. So let's exec into the pod and do wget on this. Now let's cat on that file TCP events that we have created. And we can see that there are two entries in the test pod namespace for the wget and PID. So it gives you that TCP information, very low level of information here. So let's try another one using a top file. This top file gadget is used to visualize reads and writes by the file with the container details. So on one hand, we have the container which is deployed over here. And on the other hand, we have the node, and this is giving, the reads and the write operation which is there. So you can see we have gadget top file my pod, and in another terminal, let's create a pod. It will install Git and clone the Linux source code, and we'll be able to see the files that are read and written by the pod. And we can also see the command. So let's see here. In the command, it's Git. So this particular thing is doing Git of that particular repository. So like this, there are multiple gadgets which can give you, traces the network traces, the DNS traces. I think these are very fancy as well. And even the OOM. Let's try the oomkill one. That's my favorite one, right? So what we'll do is we'll apply this particular file out of memory pod kill. Let's clear this. So namespace oomkill and the namespace pod. And now let's try the gadget to trace the oomkilled. So we have everything ready. Now we'll trigger the OOM. So let's trigger the OOM over here. And we can see that there is a OOM trace that has been captured. I think this is really fancy. So the traces are really good. We can have the TCP, TCP connect, mount, exec, DNS, all these traces being captured. So very fancy gadgets. I think it's a mix of different tools that you can visualize from the same Inspektor Gadget. So we have seen a lot of tools, and there are a lot of other tools as well, like CPU profiling. We can try this one as well. Profile the CPU gadget takes a sample of the stack trace. So let's run this particular pod. So we have created this pod, and the pod is running. And when we see the Inspektor Gadget profile CPU for the random pod, we can see that there are entries, and the command is cat, and it is trying to spend time in the unrandom read. So you can see where it was spending the time. So I think that's pretty fancy. It gives you a lot of details of various gadgets and various things happening with your system. So in this video, we explored about Inspektor Gadget, what it is, how it helps you to monitor your clusters, the traces, how to use some of the gadgets, how to install it as a Crew plugin, and how you will be able to inspect your gadget, monitor the traces, monitor or even suggest the network policies based on the traffic. Even the auditing is there, and there are lots and lots of traces which are there. It is eBPF based, very fancy stuff which is there. So I think pretty useful. What do you use for monitoring your clusters at the eBPF level? I did a video on ground cover, but that's a whole SaaS solution with a fancy UI and stuff. This is more on the Crew side, more on the local side, like you use K9s and all those. So you'll be able to use this and trigger some of the immediate responses that you want to capture the traffic from a particular pod that is behaving abnormally, and you immediately capture the traffic and, analyze some of the stuff which is there from the BPF programs that the Inspektor Gadget plans to run when you create those CRs, when you create basically those gadgets or enable those gadgets and monitor the enriched value that the gadgets do. So I hope you got a gist of Inspektor Gadget. If you like the video, then do like it, share, and subscribe to the YouTube channel. And I'll see you in the next video.